Good evening, everyone. Welcome, all of you. Very good evening. Yes, guys. So, we are going to continue our discussion on 70 important questions, right? And we are continuing the practice on organic chemistry today. All right. So, we are focusing on organic questions specifically. Today, in the special classes on the Unacademy app, you will be able to see a session 5 p.m. where we had a discussion over a variety of physical chemistry topics, physical chemistry question from the previous years. So if you are interested, you can just see the recording of that session. Okay. And guys, today is Thursday, then Friday and Saturday, 3 days consecutively, we are going to be having YouTube sessions. As I've already told you, 6 p.m. is the time. All right. And yes, guys. So I'll see you all on the all of these 3 days. We are going to do practice just like today. Okay. So chalo guys, let's start the discussion. But let me inform you कि if you want a timely notifications about all the important classes and everything, you can join me on Telegram channel over here. All right. So yes, this is a first question. Question number one. Very, very important. Very, very important. Thank you, Vishali. Yes. All right. Good evening, Ibu and Lakhan. Yeah, after a long while. So, yes, first question. First question, yes, guys. Yes, option A is it? Yes, what is this reaction, guys, by the way? कौन सा reaction है ये? Yes, name of this reaction? Palladium. Some palladium catalyzed reaction. Look over here. There's palladium over here. So, yes, C. It is a palladium coupling reaction. Suji-Trost, absolutely. It is a Suji-Trost reaction. And what do we see, guys? ये देखो. From the previous years only we are doing this. So in the presence of palladium, what is the palladium going to do? सबसे पहले तो palladium is going to attach, coordinate to this alkene and then the oxide opens up from here. Epoxide open हो जाएगा. You are going to get a 5-membered ring O minus and the pi allyl complex. And the pi allyl complex. See, in the question, the stereochemistry was not given. But in the options, you see there is stereochemistry, which means let's assume that the epoxide is above the plane. Okay, we have to assume that. So if the epoxide is above the plane, I write the oxide over here. Then the palladium has to attach from below the plane, isn't it? The palladium has to coordinate to the alkene from below the plane, right? So yes, this is your O minus, yeah, OH over here. Now, from where is this nucleophile going to attack? This is a nucleophile after losing this proton. So this proton will be lost, all right, and you are going to get the molecule like this. This is a nucleophile, carbon-based soft nucleophile is going to attack on the same carbon, all right. Yes, acha, it is going to attack over here. Why? Because less hindered attack will be. Okay? Yes. 2 times SN2. All right. So basically, Suji Trost में क्या होता है? Palladium or the metal coordinates from the opposite side, and the bulky nucleophile attacks on the least hindered side, and that also कहाँ से attack करेगा? From above the plane. From above the plane. So that is retention you are getting. You are getting retention over here. अगर above the plane attack करता है, so this is your alkene to which the palladium is attached, right? और ये above the plane attack कर चुका है, so CO2Et, CO2Et and one methyl already there. Yes, so this is your molecule, right? It is option number A and option number C, both are correct. Now we are moving onwards and we have metachloroperbenzoic acid, right? So, this Suji-Trost reaction can be used in combination with many other reactions as well. ठीक है, यहाँ पे ये कॉम्बिनेशन में यूज हुआ है मेटाक्लोरोपरबेंजोइक एसिड विच विल गिव यू द इपॉक्साइड ऑन द सेम साइड एज द अल्कोहल. एलाइलिक अल्कोहल जहाँ पे है सेम साइड ऑक्सीडेशन. दिस इज ऑपोजिट, एब्सोल्युटली रॉन्ग. वन होगा. राइट, वेरी सिंपल. So first question, Suji-Trost reaction followed by epoxidation on the same side. Let's see next question. Question number 2. Major product A and B formed in the following reaction sequence. Yes, directed epoxidation because of the hydrogen bonding. Yes, guys, what do you think? Good evening, good evening. A lot of you guys who are joining now. Very good evening. This is our question 2 only. Yes, in the second question, guys, what is the correct answer? 1, 2, 3, 4. What do you think? Sure, option A. There are better possibilities, isn't it? What is the LDA going to do first of all? There is only one proton which could be extracted, isn't it? Only one proton. So, if the proton is abstracted from here by the LDA, you have a double bond, you have pH, and the cyclopropane ring is O minus. Alright, this is O minus. So this much is okay, not a problem. And this O minus is going to be logged and is going to form a silyl ether. Alright, so let's just draw the silyl ether over here. It is going to form. I am writing the O minus over here. ठीक है, OTMS यहाँ लिख रही हूँ मैं. Alright, the second step is heat, guys. What is the heat going to do? Whenever you see vinyl cyclopropane, very very important, whenever you see vinyl cyclopropane, there is a rearrangement reaction which is happening which gives you a 5-membered ring. Look at this. I'm just writing the molecule as it is, okay, so that you can see these two ends have connected और ये double bond यहाँ आ गया है. Alright, so what is this? It's a 5-membered ring now. Yes, it is a 5-membered ring. Or 5-membered ring, maybe you are having a enol ether, silyl enol ether, जिसका हम hydrolysis कर देंगे. So silyl enol ether after the whole reaction is going to give you this, right? A and C are wrong, guys. ये एकदम गलत है, नहीं होगा ऐसे. Alright, this is what you have because of this rearrangement in the presence of heat. Very important. Metachloroperbenzoic acid. What does it give you over here? It is not giving you epoxidation. It is Baeyer-Villiger oxidation. Yes. So Baeyer-Villiger oxidation, and what do you get? From the more substituted side, you are going to get the rearrangement. So ये हो गया more substituted side where there is the phenyl group. Fourth is the correct answer. Yes, yes, D होगा इसका answer. Absolutely, this is the correct answer. Yes, chalo guys. So we'll do next question. Major heterocyclic compound formed in the following reaction is. Yes. All right. So see, pyrrole. There's always a question which is asked कि जिसमें pericyclic reaction में we want to do a Diels-Alder reaction using pyrrole. ठीक है. तो ये भी वही कर रहा है ना, Diels-Alder reaction using pyrrole. So usually what we say guys, that pyrrole is not a good diene, isn't it? Pyrrole, unsubstituted pyrrole, it is not a good diene. Why? Because it is aromatic in nature, right? It is aromatic in nature. लेकिन यहाँ क्या problem है? ये देखो, this pyrrole, it has formed a carbamate, isn't it? Tertiary butyl oxycarbonyl बना दिया है N-Boc, which means that it is using the electron density into the carbonyl also, which means aromaticity decreases. So if the aromaticity decreases, now we can use this. Now we can use the pyrrole molecule as a diene. ठीक है? Yes. Obviously, it is not going to be like this, but मैं इसको लिख रही हूँ ऐसे. It is still planar only, but I'm just writing it like this, okay? So, yes, you have SO2PH on one side and the other side is hydrogen. Alright, so this is the molecule after 4 plus 2 cycloaddition, right? And what next, guys? You still have the Boc protecting group. Alright, H2PDCMUH. ये क्या करेगा? Is it going to remove the Boc group? Absolutely not. क्या चाहिए उसके लिए? Trifluoroacetic acid, dilute HCl. We need a strong acid for that. So Boc is not deprotected. What else? Reduction of which of these two double bonds? That is the question. क्योंकि आपके पास क्या है? दो ऑप्शन है. So obviously reduction of the less hindered bond. Reduction of the less hindered bond. अच्छा. Yes. हाँ, more electron rich and less hindered bond, right? Now if I give you, for example, मैंने आपको दे दिया sodium amalgam. Reduction by sodium amalgam in this molecule. So what's going to happen? Yes guys, sodium amalgam से reduction करवाने से क्या होगा? If you are taking H2PDC methanol, it is reducing a double bond. लेकिन मैंने क्या किया? सोडियम अमालगम से रिडक्शन करा दिया. Then is it going to just remove the SO2PH, just like you happen to see in the Julia olefination? Isn't it? Julia olefination यही होता है ना? Removal of this whole group by sodium amalgam. Yes. So you have a hydrogen now. Okay, so the question could also be modified a little bit and asked in a different way. So just remember the reagents. All right, very simple, very important. Chalo. Major product formed in the following reaction is. Same question has been asked in the GATE examination as well. All right. So yes, this is also a name reaction, is it? Yes, ये भी name reaction है. Chalo. So yes, what is going to happen, guys? Metachloroperbenzoic acid is first of all going to do the Heteroatom oxidation, that you know already. ठीक है. AC2, that is acetic anhydride. What does that give you? So acetic anhydride से क्या होगा? The molecule is going to get acylated on the oxygen and one acetate has become free. One acetate has become free. That is going to take a proton which is on the alpha carbon to the carbonyl as well as alpha to the sulfur. ठीक है, which has a positive charge. So this proton is highly acidic. ठीक है. What do you get, guys? You get a sulfonium ion, isn't it? You are going to get this kind of a, right, some electrophile. ठीक है. So this acetate is free. ये क्या करेगा ये acetate? It's going to attack over here. Bond opens up. You are getting a rearranged product. How does the rearranged product look like? The carbonyl is as it is, and you are having the SPH over here. ठीक है. And the acetate like this. Okay, last step क्या है? Aqueous Na2CO3. So what is that going to give you, guys? This is a very mild base only for hydrolysis. Okay, so mild base is going to attack the carbonyl, and ये जो ester है, this is going to hydrolyze in such a way that sulfur eliminates, and you are directly getting option number D. So this is Kummerer rearrangement till here, right? Kummerer rearrangement. Followed by that, you are having hydrolysis and the conversion of your molecule into the diketone system. All right, very, very simple and also important. Chalo. So once again, before moving onwards, reminding all of you कि जो Unacademy Lite का subscription है guys आपका, in which you are getting all the test series and question bank and previous year question paper for the next 6 months. It is available for 269 rupees by using the code Jagriti S Live, and the offer is going to be valid only for few days. तो अगर आपको गेट की प्रिपरेशन के लिए भी हेल्प चाहिए तो आप यहाँ से सिर्फ टेस्ट सीरीज जिसको चाहिए you can join up. Also guys, for those who are waiting for the next session to start, December 2022 का जो examination की preparation है, for those who want to start the preparation, guys, elementary detailed batch on chemical science has already started on 15th of September. My sessions will start from 22nd of September. All right, और कृपा सिंधु सर की classes start हो चुकी है. So you can join Unacademy Plus and Iconic right now, in which you are also getting notes. Okay, और ये जो आपके test series and question bank है ये भी इसमें included हो जाएंगे. Okay, and yes, notes are available as I told you on the Unacademy app. और फिलहाल के लिए guys, the Unlock 20 offer is going on, in which you are getting 20% off, और ये कब तक है? Till 16th of September. Only till 16th of September, that is tomorrow midnight. Okay, so yes, उसके बाद में ये offer चला जाएगा. So if you want, you can join up before the examination also as you wish. This is the price. This is the Unacademy subscription package for Plus and Iconic. Okay, so yes guys, don't forget to use the code, and let's move on to the next question. Important information shared already. ये देखो, मेजर प्रोडक्ट एक्स फॉर्म्ड इन द रिएक्शन गिवन बिलो इज, ये गेट का क्वेश्चन है. बहुत अच्छा क्वेश्चन है ये. देखो, वेरी सिंपल बट या कंसेप्चुअल. All right, yes. नहीं आ रहा है या फिर मुझे कमेंट शो नहीं हो रहे हैं? 1 answer, Shoaib. What about the others? 2,2-dimethoxypropane. Yeah, what's that? This is your propane, and on the same carbon, 2 carbon, dimethoxy, in the presence of para-toluene sulfonic acid, only in the presence of an acid, what will happen? It is going to become like a ketone, isn't it? Yes, एक methanol निकल जाएगा यहाँ से, minus MEOH, methanol. All right, so it's going to become a ketone like this. So just like a ketone protects the 1,2-diols better as compared to the 1,3-diol, तो ये क्या करना चाहेगा guys? It will try to protect the diol, 1,2-diol, but for that 1,2-diols must be you know, they must be cis to each other. तो इसलिए सबसे बेस्ट आंसर यही रहेगा, right? This is 1,3-diol, 1,2-3-diol protection, absolutely wrong. ये वाले 1,2-diols क्या है? They are trans. So when there is no possibility of having a cis diol, तब हम देखेंगे trans के बारे में, but here cis diols are present already, right? Yes, so this is the answer, option number C. Next question, major product of the following reaction is, yes, hi Priyanka, how are you? And everyone guys, hello. चेयर बनाकर देख सकते हैं, बिल्कुल देख सकते हैं शोएब, चेयर बनाकर भी देख सकते हैं, but you know, it's very clearly visible. All right, so this OH is going to be over here. This is a diaxial one, right? OH. ये OH above है, ये OH भी above है. These two are going to be more preferred, right? Yes. चलो. So Me2SO4 NaOH in the first step, HCl and H2O in the next step. Yes, Yogesh, we have done plenty of questions like these in the plus classes. बहुत सारी practice कर चुके हैं हम, वही उसी में से एक example है ये, which has been asked in the exam. So absolutely guys, what is this reagent? Methyl sulfate, dimethyl sulfate. वो क्या कर रहा है? It is just being used as a methylating agent. All the OH are getting converted into methoxy, right? Yes, in the first step. और second step में क्या होगा? Only the anomeric OH, the anomeric OMe, which is what we call the pyranoside, that is going to be hydrolyzed. The remaining will be as it is. Okay? Because ये क्या है guys? ये कोई ether linkage नहीं है, right? This one, this is not an ether linkage. Why? Because there is a acetal over here, right? It's the acetal linkage. It is an acetal linkage, and that is why it is more labile as compared to all the other. ये सब क्या है? ये सब तो ether linkage है. These are all ether linkage. ठीक है? So in the presence of acid, dilute acid, only the acetal linkage is going to break to give you the OH over here. Very, very good, all of you. Let's move onward. Next question. The major product S and P formed in the following synthetic scheme are. All right. Okay, so guys, you can also see one more thing. Every Thursday, Friday, and Saturday we have sessions. ठीक है? Thursday, Friday, and Saturday we are going to have these session. YouTube session आपको पता ही है. The timing is 6 p.m. But for your examination, as you can see in the playlist itself, all right. एक हमने session करा है 16th September को. 16th September को we have kept another session again at 6 p.m. All right. So that is most scoring questions. ठीक है, तो आपको मिल जाएगा in the playlist most scoring questions 16th September को 6 p.m. All right. चलो. So yes. All right. चलो. So what is going on over here, guys? What is this reagent? First of all, in the presence of sodium hydride, you are going to get the कार्बाएनाइन over here. Yes, you're going to get the कार्बाएनाइन over here. आपको पता है क्या बनने वाला है? This is your carbonyl phosphonate ester. Phosphonate ester, right, is going to give you Horner-Wittig reaction. क्या बनाता है? E-alkene. All right. So what is the E-alkene basically? यहाँ पे आप E-alkene मानोगे where the OH is on the less hindered side, right? This is having more priority, and on this side this is having more priority. So it's going to be either A or B. ये देखो, both of these on the same side will become Z-alkene. So C is wrong and D is also wrong. ठीक है? Yes, A and C में क्या difference है? ये देखो, इसका configuration का difference है प्रिया. यहाँ पे ये Z-alkene हो गया है. Give the priority order. ठीक है? First priority on this side, second priority. इसका first, इसका second. तो ये Z-alkene हो गया ना? And this is the E-alkene. Give the priority order. अच्छा, मैं यहाँ दिखाती हूँ priority. So first priority over here, second over here, on this side 1 and 2. तो ये हुआ ना E-alkene. Okay? Based on the priority you can set the alkene, right? So this is going to favor the E-alkene formation. फिर वो alkene है, उसके पास ester है alkene के पास में, right? Ester is going to get reduced by lithium aluminium hydride into allylic alcohol, exactly just like in A and B over here. Okay, अब देखो D minus DET. माइनस DET क्या करेगा? Minus DET plus DET gives you refacial epoxidation. Minus DET gives you psi-facial epoxidation. Isn't it? Psi-facial epoxidation. तो क्या करेंगे? We are just going to find the re and the psi face. All right. ये देखो, कहाँ से find करेंगे guys? On this carbon which has the allylic OH. So give the priority order. This carbon is connected to the alcoholic group. So first priority, second priority to this carbon connected to two other carbons, third to the hydrogen. 1, 2, 3. मतलब क्या हो गया? 1, 2, 3 is anti-clockwise. मतलब कि टॉप से देख रहे हैं हम लोग. So top face is the psi face because of the anti-clockwise motion. And psi facial epoxidation has to happen. तो कहाँ ऑक्सीजन ट्रांसफर होगा? On the top. That's why this is the answer. Okay, and this is wrong. Based on the chiral reagent, you are able to do the sharpless epoxidation. Plus DET होता तो opposite हो जाता, right? Yes, very very simple. This is. So now guys, we are going to discuss more of such questions in the next session, जो आगे आने वाला session है. That is tomorrow 6 p.m. once again, as I have told you, 16th of September. All right. 16th of September, we are going to have one more session tomorrow जहाँ हम और questions discuss करने वाले हैं. And today at 5 p.m. we had a practice session on physical chemistry. If you want, you can just see the recording. 5 बजे वो session हो गया है. So yes guys, we'll continue tomorrow. Take care of yourselves and bye everyone. We'll see you all very very soon. And if you are interested in joining the course, the new course, तो आप अभी offer subscription का जो offer चल रहा है इसी में join कर लो. Okay? So yes guys, bye everyone. We'll see you all tomorrow now.